So the last time we talked, it was Friday last week. Today is December the 4th. The test on engine operation in AMT 31 is this Friday, December 8th. I sent a text to Mr. Asman to confirm when the final exam would be in this class. I looked in the course catalog, the schedule of classes rather, and it says this class will have a final exam on Friday the 15th at 9 o'clock, but I'm confirming that with Mr. Asman. Hopefully he'll get back to me today. As soon as I hear from him, I will let you know. In the meantime, test on Friday. So the last thing we did was me just rant on and on about nuclear weapons flying a B-52, which this slide is still not testable. This slide is still not testable. I've seen a CH-46 or CH-47. That's a big old honkin' twin-engine helicopter. Where literally, let's see if I can get this going here. Where literally there is a hydraulic accumulator, and here's the turbine engine, and the starter motor was actually a hydraulic motor. And this accumulator, if the pressure inside the accumulator went down, there was a valve, and you could pump it up by hand. Actually, and this wasn't the main turbine engine. This was the APU. So you actually started the APU with a hydraulic motor. The hydraulic motor was started by hydraulic power in a hydraulic accumulator. So you actually needed no battery power whatsoever. And you could get the APU started, and then the APU would provide pneumatic power to start the two main engines. Rather funky. I'm sure there's some other helicopter or aircraft somewhere that has that same system. I just don't know what it is. And then an air impingement starter goes like this. So here is a turbine engine, and I worked on T-38 aircraft in the U.S. military, and they had J-85 engines on them, and they were straight turbojets because they were out of the late 50s, early 60s. And there was no starter motor on the engine, no pneumatic starter, no hydraulic starter motor, no electric starter motor. An air impingement starter actually took bleed air off of a ground power cart and blew through a little duct, blew pneumatic air, pneumatic power, through the turbine section, and that's what got the engine up to speed. So it saved weight. You had two starter motors you didn't even have to have on the aircraft. Question? You can't. Let's put it this way. The question is, can you start the engine up in midair? And the answer is maybe. If you're flying fast enough for speed because the other engine is running and maybe you're in a dive, can you blow enough air through the engine but be spinning fast enough to relight the engine? And the answer is no. Pilot operating handbook for that airplane. I just thought it interesting that it doesn't have a starter motor. A starter motor is not installed on the aircraft. All right, so let's go back to things that are going to be on the test. So I believe some of this. So here's some pictures of some APUs. This one here ought to look a little familiar if you have a different oil sump. This looks vaguely familiar. It's hard to see. There's actually a little curve right here. These are some very nice large APUs. If somebody was standing next to this APU here is about 5 feet long, and this APU here is about 7 feet long. It's very large, literally 500 or 800 horsepower. So you are going to find APUs, auxiliary power units, on the same aircraft that have pneumatic starters. Effectively, they have 400 volt AC systems. On the other slide, I put 400 volt AC systems. And I'm not going to ask you which Ford type aircraft. We're going to say that they have very large turbine engines. So I'm not going to ask you what Ford aircraft. They would be transport category jets, that's airliners, big ol' honkin' biz jets, big ol' honkin' turboprops, and big ol' honkin' turbine helicopters. But if it's got an alternating current system, how well do batteries provide power for AC, for alternating current? They don't do it that way. You actually have to have an inverter and change the DC into AC, and then you got to bump up the voltage from that 28 volts to 400. So you're not going to find a DC starter motor on an aircraft that has an APU, except you might find the DC starter motor on the APU. Ta-da! So all the APUs you're going to see in civil aviation is going to have some kind of a DC starter motor, whether it's a DC starter generator or whether it's just a starter motor. For the purposes of this discussion, doesn't make any difference. But you're going to need a 28-volt battery, and the starter motor on that APU is going to run off of 28 volts DC. I've never seen an APU with a starter motor that ran off of 14 volts. Never seen an airplane that had a 400-volt AC power system and not have 28-volt batteries. Of course, we've already discussed the fact that APUs are relatively automatic. Even the one we have in class, most of the steps during that engine start are done by the automatic system. Same throughout APUs across the land, across the air, across the sea. Of course, everybody knows APUs, when you start them, they go right smack to idle RPM, which is the same as operating RPM, which is the same as 100%, which is the same as red line. Yeah, APUs don't have an idle RPM that's any different than their normal operating, and they operate right smack at the red line RPM. And of course, we already know what are the two kinds of power, so this would be a great test question. What are the two kinds of power that you can get out of an APU? You can get electrical power and you can get pneumatic power. Now, most of the time, I'm not going to ask you this difference on the test, but if this APU was in an aircraft that most of the things on the aircraft ran off of 400 volts alternating current, what kind of a generator do you want to have on that APU? It's almost for sure going to be a 400 volt AC generator, because that's what most everything on the airplane is going to run. But we really need that APU on there. So let's see, we can start the main engine, or we covered this on the last one. Never mind. So APUs put out electrical power and they put out pneumatic power. And I'm not going to ask you this on the test, but you could have this APU, like for instance our T62s. It has a compressor. Does it have a radial outflow turbine on it? Okay, so air comes in, goes around, and the shaft that comes out of it drives a whole nother compressor, and that's where the bleed air comes from. But we're really not bleeding the engine, because the main part of the engine runs all by itself. We're not bleeding air off of the compressor. It has a normal size compressor. So this is really a turboshaft engine, and it has a shaft output that drives a compressor. Or what you could do is put in an extra big compressor and not have this extra, and now you could take bleed air off of it, and there'd be enough air to run the engine. In either case, everything in the APU compartment has more air power output than the engine needs. Whether it's bleeding it off of the compressor for the engine or whether it's driving a separate compressor doesn't make much difference. So here, this TPE 331 is the second most common found on airplanes in the United States. It was originally built by Air Research as an auxiliary power unit, an APU, which is what you see on the screen. It had a couple of radial compressors or centrifugal compressors, and it was a fixed shaft. There was one shaft, and all the compressor blades and all of the turbine blades that rotated were all bolted on the same shaft, nice and simple. But as you can see in the diagram, or it's hard to see in the diagram, the output shaft was driving another compressor. So this right here, that was the engine. And that output shaft came in here, and it's hard to see, but there's actually another compressor. and they don't show it very well, but you could bolt an AC generator on it. And it worked out great. It was a great engine. And then somebody said, hey, this thing puts out 500-600 horses. Why don't we put a different gearbox? Let's take the compressor and let to reduce the RPMs for a jet engine. And the engine spins around, I don't remember what it is. It's something like 30,000 RPMs. And that propeller output is probably 1,500 or 1,800. So literally, you know, accessory gearbox, a big chunk of this. But that gear originally started out as a PU. So it's still a we just now turbo prop engine, because instead of driving an output shaft to spin a compressor or an output shaft to drive a helicopter. And they make these in Phoenix, right next to the airport. Let's see, Air Research bought out by Garrett. Garrett bought out by Allied Signal. Allied Signal got bought out by Honeywell. So now this is it's a Honeywell. It's like on the fifth company that's owned that manufacturer. So now it's called a Honeywell TPE 331. Question? TPE-331. Very popular turbo prop. It's got about the same shaft power as P practices. And it's, pardon me? It's a lot of people would still call it when it became popular as a turbo prop. I went and did a tour of their facility down there when they were Allied Signal. It was an Allied Signal TPE 331. You don't have to draw a picture of this on the test, just to be clear. And of course, APUs, if it's in an aircraft with an alternating current system, it's very, very likely that the generator, the electricity it puts out, is AC. And this just some more closer pictures. This curve right here, and this thing probably right here, is between 12 and 18 inches in diameter. So you could have one pretty big old honking generator. And in fact, it's very common that the APU will have the same size generator on it that the main engines have. So you could run half of the electrical equipment on the airplane while you're still on the ground really easily. And that would be really nice if you were into logistics and that generator on the APU was identical, APU on the left engine, the generator, and identical to the generator on the right engine, so you could keep one spare generator in the hangar, but if any of those three generators quit, you'd have the correct one. So there's a lot to be said for having that same AC generator on your APU. And I guess I have a little more. Whoops, why did that go away? All right, we already covered the fact that it's got pneumatic power and electrical power. We're going to say that they all do that. And really, they're just small turboshaft engines. And what are the two things they drive? Of course, we know they drive an AC generator. We already covered this. And some kind of compressor. Whether it's an extra big compressor or a separate compressor doesn't make much difference, because we're going to get pneumatic power on it, out of it rather. And of course, we already know that the APU provides power during, and this is really main engine start. So if you were going, somebody was going to ask you, where does the power come from on that aircraft to start the main engines? Well, the first thing you're going to say is it's pneumatic power, and then the next question would be, or the next answer would be, where can you get pneumatic power? We covered this a day or two ago on one of these large aircraft that have pneumatic starters on the engine. Where are the three places you can get pneumatic power? Isn't there three? The other engine, once it's started, it can provide power to the pneumatic power system. Go ahead. A ground. into the what we're doing. We're talking about the APU. And just so you know, all of those can also provide that pneumatic power into the pneumatic system. Now you can run the air conditioner and the heater on the ground and keep the passengers comfortable, which is generally what happens. All right, I want to talk about how to operate a turbine engine. So fortunately, you're all going to get to fire up a turbine engine at least once before you get out of here. Mr. Ritchie told me, I don't know, he's probably told you what he's doing during Christmas break. .404 turbofan, low bypass turbofan engine, supposedly complete. Unfortunately, caveat that we promise never, ever, ever to start it up and run it. Does anybody know what an F404 engine goes into? 15. AMT with dealer. They don't want bad press. Well, supposedly, Mr. It's complete. It's got everything bolted on it. We'll see. We'll see what's. Well, in any case, so that really got me going. So what I want to do this summer, if I'm still here this summer, is Davis-Monthan Air Force Base and other military bases, but Davis-Monthan has a lot. They have auctions of surplus military equipment, but prior to the auctions, they give not-for-profits like colleges a shot at picking it up, and you pay about 10% of what its current market value is, and usually the current market value is really low. So I'm thinking we need to pick up some jet engines, because they don't make you sign any paperwork about what you're going to do with it. I'm not saying we need another 404 engine, because it would burn a lot of fuel. It's probably 5 or 10 gallons to start it and get it to idle. But maybe a smaller engine would be pretty nice. In any case, so you're going to go and you operate a turbine engine. So things that you're going to need to check. You're going to turn on electrical power, and you're going to check how much fuel is in the tanks. You're going to see if the magnetic chip detector lights are on. You're going to look for fuel and oil leaks on the ground, on the bottom of the cowling. You may or may not be opening up the cowling, but you might just be going out for an engine run. So wherever that airplane is parked, you're going to look on the ground and see if there's any fuel or oil leaks underneath the engine. You can look at the bottom of the engine cowling and see if there's anything there. You're going to look at the discrepancy list. So I want to talk about the discrepancy list here for a minute. If anybody let's think about a Boeing 737 or an Airbus A320 that the version we're talking about holds 100 people. How many things can go wrong on that aircraft, but still the aircraft is safe to fly? Yeah, what if one of the toilets doesn't flush? Do you want to cancel the flight? Well, maybe the flight attendants would prefer if you canceled the flight, and maybe the customers might, but you're probably not going to cancel the flight. You ever notice in the wing tips they put in 2 position lights in each wing tip and in the tail, so if one burns out, they still get it going. They don't even have to fix it. Hopefully making an assumption there's a second bathroom. Sorry, just to be clear. All right, what if one of the coffee pot makers doesn't work? What if one interior light doesn't work? So there's a thing called a minimum equipment list, and I'm not going to get into it a lot today. The minimum equipment list, and the FAA says if you buy a jet aircraft, whether it's an airline or not, and you write the manufacturer will write up a minimum equipment list and say, fly under these conditions, it's okay if these things are broken. So what you do is, whether you're an airline or you're just a business or a personal person, a private citizen, and you own an aircraft, and you can do this. Usually it's very commonly done with turbine-powered aircraft, is you take that master minimum equipment list from the manufacturer and you start adding to it of all the things you put in the aircraft. Let's talk about that 737. What if somebody's TV screen on the back of them has burned out? The passenger won't like it, but do you want to cancel the flight because one person's TV set's burned out? No. What if you're a business jet and the built-in blender that's bolted into the bar, the wet bar in the back, the blender is inoperative. Now, the owner may cancel the flight because they can't have margaritas, but generally speaking, you don't want to have to cancel because something's broken and it isn't required for the aircraft operation on that flight. It's not required to be safe. It's not required to be there and working in order to be safe. So this list is big on airliner. This list is pages and pages of things that can be broken and still get to go flying. So the reason I'm bringing it up here, if you're going to run an engine, maybe there's something that's not operating on the aircraft impact whether or not you get to run that engine. Now, it's not very likely. Discrepancy list. In the service, the U.S. military is a little different than the airlines are. We had equivalent to a minimum equipment list already made up. And when we drive in our bus out to that airplane, the aircraft commander would flip through it and read out loud all the discrepancies that were currently wrong with the airplane, but no one was planning on fixing them before we took off. And the reason he was reading them was so we would all know what equipment was working, what equipment was not. Like, for instance, that aircraft had the aircraft I flew on had 4 AC generators. It had an AC generator on engines 1, 3, 5, and 7, and it had a hydraulic pump on engines 2 and 8. So if the pumps wasn't working, we still go. So it's probably a good idea if you're going to run that engine, then the AC generator doesn't work. When you're trying to flip the switches to get the AC generator to come on, you're going to be wondering how come the generator doesn't work. So when you're going to go out and start up a jet engine, you need to flip through that aircraft discrepancy sheet that has all those outstanding things that are broken, but the aircraft is still okay to fly, and see are any of those going to impact whether or not I can run this engine. So I'm telling you, this is on these list of things you need to check before, and this is not included. You could argue this is not visually inspecting the engine. You might not notice it. So you're going to look at that list of discrepancies to see if there's anything that's going to impact whether you can run that engine or not. Obviously, you're going to check oil level. I've seen modern airliners with oil level gauges in the aircraft cockpit on the TV sets. And of course, same thing for fuel level. Of course, when you're giving the engine a flight, you're going to look around and say, is there anything around here that's going to get sucked up into the engine? Or are there ground personnel walking around? Do I need to fence it off? Is there a beehive, on a pole 20 feet away? So now I'm going to actually go and look at the engine. So you're going to take a quick look inside the engine and just look around and say, is there anything coming loose inside of the intake? Not likely, but take a quick look. Obviously, you're going to look at the fan or as much as you can see them. On some engines, they're hard to see. But you're going to take a quick look at the blades. Is there any obvious damage? And if your engine is a turbojet or a turbofan and it has an EPR gauge, or sometimes called EPR, I'm not making that up. Sometimes it's pronounced EPR. You will not have to pronounce that on the test. You're going to look at the EPR probe and see if there's anything stuck in it, because it's like a pitot tube. Doesn't look like a pitot tube, but it's got a little opening in it. You're going to look to see is there any insects or dust or dirt stuck in it. You're also going to look in the exhaust. Now, granted, this is based on all you're going to do is an engine run, and you didn't do any maintenance. Obviously, if you had just done maintenance, you probably took a good look inside of the engine compartment. So is there anything in the back of the engine that shouldn't be there? You're going to take a quick look at the turbine blades to see if anything's wrong with them. You may or may not be able to see the thermocouples. If you do, this would be a good place, or a good time to see. You're not going to get close enough to actually see the little tip of metal where the metal is welded together. But I've actually looked in the tailpipe of an engine and saw one of the thermocouples broken off, and it was missing about a half of an inch. And of course, there might be an EPR probe. Of course, the opening for the EPR probe is facing forward, and you're looking from the tailpipe, but at least you can see if it's there. You can look for exhaust damage. I gotta fix this. There we go. These things were getting dim after I talked about them. There we go. Looking for damage on the exhaust duct. I think there's one more. And if you've got thrust reversers on the exhaust, you're going to be grabbing them and trying to shake them a little, not a lot, to see if it sounds like anything. So it really depends on, are you pre-flighting the aircraft because it's going to go flying? Am I pre-flighting it or doing a visual inspection of the engine just because I'm doing an engine run? So how many steps may vary a little bit. So before engine start, you're going to look in front of the engine, make sure you're not going to suck anything up. You're going to look behind the engine and think about where the exhaust is going to go. Am I going to knock people over? Of course, we already talked about sucking up foreign object damage, sucking up foreign objects. You're going to want to make sure that that ground power unit, if there is one, that's an if there is one, is connected to the aircraft and turned on and running correctly. Because if that plug isn't in all the way, you might get electricity, or you might not get enough electricity, or if it's a pneumatic power, if that connection isn't tight, what if the hose comes disconnected while there's 60 psi airflow in it? Most household water pressure in the United States is somewhere between 40 and 60 psi. Think about a fire hydrant with a 3-inch diameter opening. A fire hose with a 3-inch diameter opening at 40 or 50 or 60 psi. Is there some power in there? Yeah, sometimes it takes 2 firefighters to handle that hose, although I think they do, if you've got a truck, I think it bumps the pressure up some. In any case, that's a lot of power. Do you really want that hose flopping around? Has anybody ever been hit by a hose? Anybody been hosed? Didn't I talk about getting hosed? No, I didn't. You got to hold a fire hose? Yeah, they pretended to let you hold it. Well, that's awesome. Ah, they might not have turned it all the way up. Generally speaking, there is a gauge inside the aircraft, and it's going to be pneumatic power, or the pneumatic system pressure. And you're going to want to know what is the minimum amount of pressure inside that pneumatic system for the main engines to be started correctly. Whether you started up the APU and it's providing power, or you started up a ground power unit and it's plugged into the aircraft and it's providing pneumatic power, or you started one of the other main engines and it's providing pneumatic power, there's typically some minimum PSI you need to look for before you attempt to start on the next main engine. So you might want to get a clipboard and write some of these things down so that when you're out at the aircraft, you have them right in front of your face. Of course, you really need to have an engine starting checklist that the pilots would use to make sure that you don't forget anything. I want to talk about heat soaked. I'm going to ask you this question on the test, 99% chance. Heat soaked, I'll describe the situation. Somebody, might have been you, might have been somebody else, or at last, inside of the engine is not outside air temperature anymore. So let's say today, for fun, it's 50 degrees Celsius out, 50 degrees Fahrenheit outside. That's probably about 12 degrees Celsius. If you shut down a turbine engine, you think it's 12 Celsius on the inside of the engine as soon as you shut it off? Okay, everyone except Elizabeth is correct. It's not going to be 12 degrees Celsius inside the engine because it's going to be hot. You turned off the fuel, that's true, but you also turned off blowing cold air through the engine. So the metal inside the engine is all going to be hot. And in fact, if you sit there and watch that exhaust gas temperature, the exhaust gas temperature, I'll make up a number, let's just say it's at 500 degrees Celsius. You turn the engine, shut the fuel nozzles off, and the engine starts spooling down. And you look at the EGT, and the EGT will start to go down, but it won't come down to 12 degrees Celsius. It might only come down to 300 degrees Celsius. Well, that's like 500 Fahrenheit. So let's say 5 minutes later, 10 minutes later, you're doing work on the engine, you adjust something, and the engine says it's 208 degrees Celsius. The last time you started the engine, it was at 12 degrees Celsius. Now you're starting the engine, it's at 250 degrees Celsius. When I start the engine now, what's going to happen to the EGT as compared to the first time I started it? It's going to have a higher EGT. So the fact that when I go to start the engine, it's still hot from the last start, that term is heat soaked. So if I said define heat soaked, that's when starting the engine, inside the engine, let's start over. Heat soaked is still hot from the previous engine run. Last time the engine was on. For fun that the red line EGT is 1,000 Celsius. And when I started the engine, it goes to 800 degrees. Problem. Well, when I start it up this next time, it's not going to go up to 800. It might go up to 900. Of course, if that's still below 1,000, I'm still pretty happy. Seen Turbine Engine pilot operating manuals say that when you go out to start that engine, heat is above a certain level because it's heat soaked. For cold air through the engine and cool the engine down a little bit and then start the engine. In fact, you don't have to put it down, but I'm trying to think which engine it was. It said if the EGT was higher than 100 degrees Celsius, that you needed to motor the engine during start and just let the motor run until the EGT came down to 100 Celsius, and then you can turn on the ignition and the fuel nozzles on. Because they had had a lot of practice with this and knew that if it was above 100 degrees Celsius, the likelihood of having a hot start. So here's something you're going to need to pay attention to. Because pilots, they go out, they start the engine for an hour, 2, 3, 5, they come back in and land. Problem. They almost never start the engine when it's heat soaked. Not completely never, but hard. And the engine, adjust something, adjust it again, and you're going to need to start it up again to see if what you did soaked about 10 or 20 than it is for a pilot. So how hot can that engine be when I go to start it and I'm still have a hot start? So now when somebody says, yeah, go start out, it's heat soaked. That means it's not been very long since somebody operated that engine and the inside of the engine is hot, and I better know how hot can it be and still start the engine and be safe. And if it's too hot, can I motor the engine to blow cold air through it, or can I not? Question. Generally speaking, there's not the question is there a time limit or a time between engine starts? When you shut it down to the next engine start, I've never seen a time limit. The only thing I've ever seen is this is the maximum GT you can when you go to start the engine. So you shut it down and then literally 30 seconds later start it up again, but the question is it now too hot on the inside? So you're either going to have to wait until the engine cools down, or you're going to have to motor the engine with the starter and not turn on the fuel and the ignition. motor the engine and blow cold through the engine, and when the temperature gets cold enough, now you can start the engine. So I've not seen a time published. Does that answer your question okay? Yes?
If you're not able to use the motor engine portion of it because
Starter.
ran its duty,
Yeah.
could you put a fan in front of the engine to blow air through it?
The question is, if you can't use the starter motor for some reason, like the starter duty cycle, can you put a fan in front of the engine and have that do much good? And the answer is that would be an insignificant amount of good. Because you've got to really blow air in a reasonably high volume through the combustion section and the turbine section. And I'd be surprised if a fan has that much power to even get the engine to rotate really, 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 really slow. I'd be very surprised. So yeah, that's right. You might be stuck and go, well, I've hit my duty cycle. And so maybe that means you got to wait. That means go get a cup of coffee. It must be break time. Read a magazine. If it was some kind of a gas turbine-powered fan, yeah, just put another jet engine in front of it. Nah, probably not. It's humanly possible. So here's the things that if you were going to go start a jet engine, that I would want to have written down. Whether, even if I had a checklist with me, telling me what steps and telling me some numbers, I'd want to have this stuff written down. If you get used to working on the same engine over and over, at some point you might have these things memorized, but for a while you're going to wish that you had it written down. So you're going to want to know what the starter duty cycle is. Obviously, if it's a pneumatic engine, what is a typical pneumatic starter duty cycle? Indefinite. Typically, they don't have a starter duty cycle at all. You can spin them around forever. What is the ignition duty cycle? We haven't talked about it. There are some ignition systems that operate very similar to electric starter motors, and that they get hot. When you run electricity through an ignition system, they use a lot of power, and it's not the igniter in the engine that gets hot, it's the exciter box that's bolted on the side of the engine. That's what you're likely to fry. So you need to look and see, is there a duty cycle for the ignition system? Of course, we already talked about the fact that if you're using a pneumatic starter, there may be a minimum PSI. But if you're using an electrical starter motor, and it's coming from a ground power cart, are there any gauges on that ground power cart to tell me, am I at the right voltage? Is it going to put out the correct amperage? Just say for fun, whether it's a pneumatic starter that's not getting enough air, or it's an electric starter that's not getting enough electrical power, what's going to happen during start? Either of these things could cause one or two things to occur. Go ahead. You could have a hung start, that's correct, or you might have a hot start. That's right, because either of these two things, not enough pneumatic power or not enough electrical power going to the starter, the engine's not going to spin as fast as it's supposed to. That means the engine won't have as much cooling air going through it, and when the fuel control comes on, it's going to squirt in the amount of fuel into the engine, making an assumption that the correct amount of air is there. So it's going to get too hot, or it's going to hang up, or both. These abbreviations are FF stands for fuel flow, and PPH stands for pounds per hour. PPH stands for pounds per hour. We already talked about the fact that if we were going to start the engine and we had a no start, one of the things we were hopefully looking at is, did the fuel flow rise up above zero to tell us that now there might be fuel puddled in the engine? Or if we had a hot start, it would be nice if we knew what the fuel flow was and compare it to what normal is. So you may not have this number. It may not be published. You could ask another mechanic who's worked on these engines before, or maybe you start paying attention to it during your engine starts so you know what's the normal fuel flow when you turn on the fuel nozzles, and what's the normal fuel flow when it gets to idle. What is that normal amount? Is it 500 pounds an hour? Is it 600 pounds an hour? Is it 10,000 pounds an hour? Every engine's going to be different. So I believe that if you're going to go right and start an engine, you have to have some things to memorize. Minimum, it's on your clipboard right there, so you can look at it, and you might actually want to read it over 2 or 3 times just before you start the engine. Start a jet engine by yourself, no matter your first time, no matter how long you've been working there. Huh? They don't have to know. I think they're going to. Yeah. Okay, so there's some things that you just really need to not have to spend time looking for. Of course, this is the most important one, right? So if I was going to ask you this question, what's the fastest way to destroy a turbine engine under normal circumstances? Starting it. Why? Well, there is a lot of things that go wrong, but what can you do to a turbine engine that will, in the least number of seconds, destroy the engine and have to not just overhaul it, but replace internal parts? Yeah, have the EGT go above redline. And you can do that in a few seconds, 5 seconds, easy. How long does it take to destroy the bearings in a turbine engine if the oil pressure doesn't rise? You got at least 30 seconds before it has to start moving, so obviously you can spin the engine for at least 30 seconds before you fried the bearings in the engine. But EGT exceeding redline, if it goes above the redline at all, you're toast. And unfortunately, so is the engine. So knowing exactly what that EGT is, now what the great news is, you're going to find gauges that have the redline. But I have seen some gauges that only have one. I've gone out and looked at a flying machine, and there has been one red line. And the question then became, if I hadn't looked in a manual, is this a red line for EGT during start, or is the red line EGT for all other engine operations? Most turbine engines have 2 red lines. I'm going to say that again because you're going to write this down. Most turbine engines have 2 EGT red lines. One of these EGT red lines is during start, and the other EGT red line is for all other operations. Can't spell start. Now, there are some EGTs that have 2 red lines on. If you ever operate a nice new Boeing 757-67 and Airbus, the computer and then after you start, red line goes away, and the new EGT two red lines. A lot of gates have 2 red lines. No, I would not show passengers exhaust gas temperatures. Because they'd say, what? It's 1,000 degrees Celsius. The engine is melting. Ah! Would both of the red lines be engaged? The answer is yes. The answer is yes. So literally, if this was an EGT gauge and it had both of them, which is very common but not always, there might be a red line over here, and this one might be for start. Some yes and some no. The question is, would they be labeled differently? I've seen some that just have 2 red lines. Which one is for start and which one is for all other operations? And I've seen them reversed. I've seen one that all other operations is a higher EGT, and I've seen a lot of them where the starting EGT is the higher one. So you can't even make and say, oh yeah, the higher one, that's always the starting EGT. No, that's not true. Well, these are red lines. You wouldn't want to... This what we're concerned about right now during start is if it looks like the red line, if the EGT is going to hit the red line, we need to do the 2 steps for hot start before the needle gets to the EGT red line. We need to turn the fuel nozzles to off and motor the engine if possible before the needle hits red line. I'm going to say that again, before the needle hits red line. The TPE, the C250s out there, those little helicopter engines, man, the first time I ever started one of those, I shut it off. I thought I was having a hot start because the EGT rose so fast. It was going, yahoo! And then it slowed down. And then it came back down. But literally, from right here, from where I lit it off to about right here was 3 seconds. That engine actually, compared to other engines, does not have a lot of inertia, so it can spin up really fast. And man, so the start sequence is really, really fast. I was so scared, fortunately for me, I was scared, and I was ready. I slammed down the switch that turned off, so I turned off the fuel nozzles, and I kept my thumb down on the starter motor, and I'm like, holy crap. And then I called somebody up, and they go, oh, yeah, man, they start up like that. They just go, woohoo, until they're about 1 or 200 degrees below red line, and then they stop, and then as the engine continues to accelerate, the EGT goes down a little bit. They said that was normal. So, of course, in our generic engine, of course, we all know that we're on at 0, and then at 20%, that's where the ignition comes to on and the fuel nozzles are turned on. But every engine is different. Unfortunately, it's not like recips where it starts making noise and you can pretty much it's going to be okay. You aren't even looking at the RPM gauge during the start. You're just listening. In this case, you're not listening. A lot of jet aircraft, you're so far away from the engine when you're operating it, you can't use any sound to tell you much of anything. So I would recommend that you have what is that RPM. If you're the person, if you're the mechanism that turns on the ignition and the fuel nozzles, you need to know what RPM that is. And of course, you need to know when you get to let go of the starter switch. That may be even more important because what's generally question? What is likely to occur if the person starting the jet engine lets go of the starter switch prior to the self-accelerating speed? It's going to pretty much for sure cause one thing, and then it might cause another. What's it for sure going to cause? You let go of the starter switch before self-accelerating speed. It's going to be a hung start pretty much for sure. And can also turn into hot starts. Yeah. So you think it's kind of important to make sure you hold the switch down long enough? The biggest mistake people make when they're starting jet engines, it's the operator making noise, they let go of the switch. So in a jet engine at 20%, I know it's our jet engine, we turn on the ignition, the fuel, engine makes a lot of noise, starter. But in engine, our generic engine, we keep the starter switch pushed down all the way till 40%. Self-accelerating speed is about 30% or 35%. So this is very important to know, when do I get to let go of the starter switch? And of course, one of our steps is make sure that the engine RPM accelerates to idle. Well, if we don't know what idle RPM is, then we won't know if it accelerated. We won't know if we have a hung start. In a recip, it doesn't matter too much because all reciprocating aircraft engines, they're going to idle around 500 or 600 RPM, and we're probably going to push the throttle up and let it warm up at 800 or 1,000. And that's whether it's a Continental, a Franklin, or a Lycoming. I'm trying to think of another one. Another reciprocating engine built in the United States that goes on airplanes. And Franklin's not built in the United States anymore. But that's pretty much all the same, even whether it's turbocharged or fuel injected or carbureted or whatever. Turbines, on the other hand, they all have different idle RPM. So you're going to need to know what it is, because if you don't know what it is, you won't know if you have a hung start. And if you don't know if you have a hung start, then you won't do the hung start procedures. If you do not know what the hung start procedures are, I highly recommend you learn them before the test. And I've talked about this before when we went over that list. The point of me making you memorize verbatim in order the 8 generic jet engine starting checklist items is because regardless of the engine, how big, how small, who made it, all 8 of those things have to occur. The only real question is, are you going to do it when you're starting the engine, or are the automatic systems on board the aircraft going to do it? For instance, the ignition system on most turbine engines is typically wired into what switch? There's typically not an ignition switch on turbine engines. It's typically hooked into what switch? The starter. So most of the time, in fact, nearly all the time, you as a mechanic will never be pushing the ignition switch in because it's wired into the starter switch. So when you push in the starter, the ignition comes on, and when you let go of the switch, if you forgot to turn on the ignition switch, you went to start the engine, and you forgot the ignition step. You get to 20%, you don't turn on the ignition, but you forgot that you're supposed to do that. What's the next step after ignition on? Fuel. Fuel, nozzles on, very nice. Yeah, so we're just going to be squirting fuel into the engine, and it's not going to catch on fire. So we'd end up with what kind of a start? The fuel never caught on fire. What kind of start are we going to have? The fuel never caught on fire. It's not a hung start. It's not a hot start. It's a no start. Yeah, I got you all freaking out about hot starts and hung starts. That's good. But there's also no starts. So you need to know what are the steps the system is going to take for me, and what are the steps that I have to do as the operator. And then, of course, one could argue, of all the things that you screw up or how to do, this is arguably the one that's most important for you to know exactly. How do I get fuel nozzle to stop squirting fuel into the engine? It's going to vary. Every engine installation is separate. You know, if it's a piston-powered aircraft engine, how do I get from stop going into the engine? Every reciprocating engine that you've ever seen, how do you get the fuel getting squirted into the engine? The mixture, the red lever, pull it all the way back. Ta-da! Whether Boeing made it or Continental made it, whether it's fuel carbureted, supercharged, turbocharged, there's that big red lever there. Nice. But in turbine engines, it might be a switch. You might have to pull the throttle back. You might have to pull the throttle and lift it up past the detent. And then also, of course, this is more of, can I re-engage the starter if I let go of it? It depends. Yeah, that's right. Can I turn it? Not where the starter switch is. If I let go of it, is a transport category jet airliner. It's a huge turbine aircraft, and it has big old honking jet engines on it. If I have 40% and I have to go starter motor to re-engage, once I push down on it's a transport category jet airliner with a very large engine in it. So what kind of starter motor is going to be on very large jet engines? I'm only going to talk about 2 kinds of engines when it comes to starting. Big ones and little ones. Do you know the answer? There is one aircraft on the planet that is an airliner that does not use a pneumatic starter. And I hesitate to tell you what that is, otherwise you'll get it wrong on the test. So do you want me to? Yes. The 787 pneumatic system. There's only one thing on the entire aircraft that uses off of the engines. Oh, inlet heat. It takes bleed air, a little tiny bit of bleed air right off the inlet ring. That system on the entire aircraft. On a 787, air compressor, pump air. Instead of having pneumatic systems, they have a lot of electric wires and really, really, really big generators and really, really, really big starters. So on the test, I'm not going to say, other than the 787, I'm not going to say that. No, that's okay if I don't? Or no, I better say it? Excluding the 787. Man, that's a good time to stop. Don't worry, I got more tomorrow.